In this video, we're going to talk about two more shortcuts for proving triangles are congruent. The first one for today is angle side angle. Angle side angle, or ASA congruence, says if two angles in the included side of one triangle are congruent to two angles in the included side of a second triangle, then the two triangles are congruent. So if I have my figures here, if I know this angle is congruent to this angle is congruent to this angle, and the included side are congruent, then I can say they're congruent by angle side angle. When I read the figure, I've got angle side angle and angle side angle. Our second property for today is angle side, or AAS congruence. If two triangles in a non-included side of one triangle are congruent to two angles in a non-included side of a second triangle, then the triangles are congruent, and we have our figures there. First example says, is it possible to prove the triangles are congruent? If so, state the postulat or theorem. So when I'm looking at this figure here, I know that angle G is congruent to angle E, and I know angle C is congruent to angle F. I can conclude that GDC and EDF are congruent by vertical angles, but I don't have angle. The lengths of those sides could be different for each triangle. I don't know anything about any of the sides, so for this one I would have to say no, I can't determine if those two triangles are congruent or not with what's given. The second one, we have angle HIK is congruent to angle JKI, and angle HKI is congruent to angle JIK, and then I have KI as a shared side between those two triangles, so I can say yes, I can prove these two triangles are congruent, and it would be by angle side angle. So what would a proof of this look like? So it says given angle B is congruent to angle C, angle D is congruent to angle F, and M is the midpoint of DF. So the first thing I'm going to do is I'm going to mark up my figure here with what I know. I know B is congruent to C, and I know D is congruent to F. I also know M is the midpoint of DF, which tells me by definition of midpoint that DM is congruent to MF. So now looking at those two triangles, I have enough to write my proof, because I can then say that those two triangles are congruent by angle side. So I'm going to choose to do statement reason. And I'm going to start with my givens. Angle B congruent to angle C and angle D congruent to angle F. I'm not inferring anything from those, it is what it is. However, M is the midpoint of DF. I can then infer that DM is congruent to FM by definition of midpoint. And finally, my triangles then are congruent by angle side.